Hi, I'm Adam. Welcome back to Godot Game Lab. In this episode, or I should say episodes, we'll introduce the trait bonus system into the game, so units can get different bonuses based on the active traits on the board. This also includes a refactor and introducing a modifier system to the game. Let me show you how this looks like in terms of gameplay data. So if I press Ctrl P, we can search for resources to edit, and if we type in viking.tras, Bjorn is a Viking, so right now how this looks like to make it easier to test is that we only have one level of activation for this trait, and we only require one Viking on the board for this to be active, which provides one bonus called Viking bonus level 1. Now how this works, in this specific case, if a Viking's HP falls below a certain HP threshold percentage, which is in this case 75%, it will be modulated to this red color, indicating that it goes into a berserk state, and this state provides a massive attack speed modifier bonus, which gives us 70% more attack speed than we usually have. If we press Ctrl P again, the elf trait works a bit differently. So if we look up elves, here we have two levels of activation. Again, one unit is needed for level 1 for testing purposes, and 3 elves are needed for level 2. Now in this case, we have two different bonuses, but the elf bonus is much simpler or less complex compared to the Viking one. If I click on it, this is just providing a modifier value to the unit. In this case, we modify the unit's attack speed, and one elf on the board provides us a 10% attack speed boost, but if we manage to put 3 elves on the board, they will have 25% as an attack speed bonus. Now in-game, this looks something like this. Let's just put a Bjorn on the board because it's much more visible. You can see that the Viking trait becomes activated, and if I start a battle, Bjorn will start attacking like he usually does. But if the HP falls below 75%, it becomes red and starts attacking like crazy, activating that bonus. Pretty cool, right? So let's get started, but before we do, just a quick announcement. When I finished recording this episode, I realized that it's crazy long. I think it's somewhere between 2.5 and 3.5 hours, so I decided to split this episode into 3 different parts to make sure that it's not too overwhelming, but you can consider it as one episode split into multiple videos, right? And this outcome shows what we'll achieve at the end of this whole process of refactoring, introducing the modifier system, and implementing the trait bonuses into the game. So let's start with the architecture overview like we usually do. Now for this episode, it will be a bit trickier, so I went into more detail explaining how and what we're going to do. Let's think about this first. What's our goal with this milestone of the project? We want to introduce trait bonuses, so if I activate 2 elves, they get an attack speed boost. Let's say that, right? So how do we need to handle this? Right now, what we have is we have a battle handler, which handles everything battle related. So it's a good guess that somehow we need to change up the battle handler. And we also do already have a trait resource, which holds all the data related to the different traits like elf or Viking or whatever. So what we want to do in this episode is we want to introduce a new resource called trait bonus. And this resource will handle the logic for applying the bonus. Similar to what we had in the AutoBattler course, if you remember, or if you did that, where we had the logic for the cards and they had the method which they had to implement. And then we could do the logic for all the different cards in the game. We want to do something similar, so what we say with this trait bonus as a base class is that they have to implement one method which applies the bonus that the trait provides. Now for the trait resource itself, we have to add an array of trait bonus resources, because the way this works in AutoBattler games is that we can have stronger bonuses the more unique units we have for that trait. So for example, let's say we provide a 10% bonus for 2 elves, but for 5 elves we want to have a 25% bonus. So all those different levels of bonuses can be split into different resources, and we don't have to recode the whole logic because we can just add export variables to tweak the values, right? So then we have an array of trait bonus resources, and what the battle handler needs to do then is at the beginning of each combat or battle, we need to apply all the trait bonuses to the eligible battle units. So only those that are active. Okay, so that's the thing we want to implement here, and an extra bonus will be actually introducing a modifier system to this whole thing, because to provide that attack speed boost, we need to have the modifier system in place, right? So the modifier system I won't detail because we already did that for the Slay the Spire course, and we'll use the same principles with a slightly different implementation. So if you're interested about that, you can also watch the Slay the Spire version or just wait for the implementation where I'll explain everything in detail. Now, let's see what problems arise when we try to create this system. Right now, the only node in the game or scene in the game that is related to traits is a UI node, a control node called traits. So what do we have in this UI piece? If you remember, we handle activating the traits perfectly well in this traits class because the active traits need to be displayed on the top part of this container, right? So we have to rearrange them whenever a trait activates. So what we do is we track activating the different traits on the battlefield inside the UI. And this is a problem. Why? Well, the problem is, if we were to introduce the new logic, where the battle handler needs to apply trait bonuses, the battle handler needs to know which traits are active when the battle starts, right? Now, we could just leave this as is and say that, okay, we provide a connection between these two nodes, right? The trait UI and the battle handler. But this is an architecture smell, and probably one of the worst ones. Why? Because think about this. What is the purpose of a UI node? It's to display information, right? It takes input data, does whatever needs to be done to display it in the most informative way to the user, but that's about it. So if my battle handler relies on a UI node to get the information it needs about the active traits, it's already a messed up system. The UI should solely be responsible for displaying that information. I should never rely on a traits control node to get all the currently active traits. Establishing the communication line between these two is not the best idea here. So we need to somehow refactor this. Now, if we take a look at the code that we currently have, we can see the culprit here. We have this dictionary called current traits. The traits to update, okay, this is needed, so we can actually keep track of which UI nodes we need to update. But this one is probably the worst. We have an active traits array where we collect all the traits that are currently active. And if we take a look at the code, indeed we can see that when we create a new piece of UI, when we instantiate a scene, we check if that trait is active or not, which is data that is available inside the UI. And if it is active, then we append it to this array. And again, we do this when we update trait UIs. Now, this is exactly what we don't want to do, right? Instead, what we want is to somehow manage this differently, right? So the UI doesn't need to do any of these calculations. We don't need to track which traits are active or not. Ideally, this whole class can just connect to a signal, which is emitted when all the traits change and has this array of active traits as an outside dependency, right? So we don't want to fill an array with the active traits here because it means that we are doing the logic inside the UI node. So how can we restructure this? What's the purpose of this episode? So we'll have our battle handler. And we'll introduce a new mediator or a new logic handling class that is responsible for tracking the different traits. We'll call this TraitTracker, and we want to sort of extract all the functionality out from the UI class that we currently have and say that this TraitTracker node can handle all the trait activation and managing logic. And then this node can notify both the UI that we currently have, the traits control node, and it can communicate with the battle handler as well. So the battle handler can apply the active bonuses to the battle units. Then the battle handler already has access to the trait resources that are on the battlefield because we have access to the battle units. So then we can just filter through all the traits that are possessed by the battle units and only add the bonuses that are active traits, right? And we can query that information from the TraitTracker, which will keep track of all the active traits. And again, just to reiterate, to actually create usable bonuses in the game that have an effect on how the game feels and plays, we need to introduce modifiers on top of all this, so we can add attack speed bonuses, AD, AP bonuses, health bonuses, and so on. So after all this explanation, let's get started. In this episode, I wanted to include the project selector screen from Godot as well, because you can see that this project, since I've uploaded the last video, was in 4.4, but there's a new major release with 4.5 recently. So I just wanted to show you the process of upgrading it to 4.5. As you can see, the reference project is already updated to the latest version. So with the project selected, if we double click on it or click on edit, we get this pop-up message saying that this will change it to 4.5. And we have a link to a migration guide, but in my experience, there's nothing really that we need to change in this particular project. So we can click on OK, and the project loads just fine. If we click on play, we can just hide the output window and make sure that everything works as it did before in the last episode. We can still buy and combine units. We can drag them on the board. And we can start a battle with all the debug information visible, and the units play out the battle just fine. One thing you can see that's kind of new is that even though these zombies or ogres have 0 mana, they still produce a full mana bar while the battle goes on. So this is a new thing, this wasn't there before, but it's something we'll fix in this episode. Okay, so with the project open and upgraded to 4.5, let's work on the new features. So the first thing is reworking the trait system. We talked about this in the architecture overview. Basically, we need to answer 3 questions. When do we want to update the traits? We want to update the traits when the unit grid changes, right? When we buy a new unit and drag it over to the battlefield. This is when we need to recalculate the current state of the traits. Now, what does it mean to update this state? What do we need to keep track of inside the TraitTracker? The algorithm itself, from a high-level point of view, is pretty simple. We count unique units per trait, right? Because if I put down 2 Arthurs, they only count as 1 Viking. And after having the unique unit count for a trait, we check if they are activated or not. And that's about it. And the third question is, how do we communicate? What do we need to do inside this TraitTracker so both this UI can remain functional and the battle handler can have the information it needs when a battle starts? Well, the best thing we can do for the UI is to emit a signal when the traits have changed. To make it easier for the UI, since we already want to decide whether a trait gets activated or not inside the tracker, we can just emit the signal with 2 parameters, one for each trait with their unique unit number count, and 1 array for only the active traits already filtered. So the UI doesn't need to think about or execute any logic when displaying these elements. So with these questions answered, let's create a new TraitTracker node. So let's collapse everything in the file system doc for now. I click on custom nodes, expand it, right click on it, create a new script, and we'll call this trait_tracker.gd. Click on create and double click to open it up in the script editor. So the first thing we're going to do is provide a custom class name called TraitTracker. Then we'll add this new signal called traitsChanged, and we'll have 2 parameters. One is called unique, and this will be a dictionary, and we'll make use of the typed dictionaries that were introduced in 4.4. So we'll say that the keys for this dictionary will be trait resources, and the values will be integers indicating how many unique units on the board currently possess that trait. And we'll have an active array, which will be just an array of trait resources with all the traits listed that are currently active on the board. Now, to have this information, we said that we need to have access to what units are currently on the unit grid. So we'll provide an export variable reference to a unit grid, which will be the arena grid. Then we'll have 2 member variables for the unique traits and the active traits, so we can keep track of that. The reason why this is useful to have these 2 member variables is, 1, it makes it really easy to emit the signal and pass the data. 2, for the battle handler, if you think about it, we don't really want to connect to this signal. We want to connect to this signal for the UI to make sure that it's always up to date. But the battle handler needs to query that information of the current active traits when the battle handler needs it. It doesn't really want to react to when the traits changed, It's rather the other way around. So when a battle starts, the battle handler requests that information from the TraitTracker. And if we keep both these member variables up to date at all times, then we can always just use TraitTracker.activeTraits, right? Then inside the ready callback, we want to connect to the arena grid's unit grid changed signal to make sure that whenever the grid changes, we can update to the latest version. Now, how do we update this information to the latest version? The first thing we'll do is we grab all the units from the arena grid, and then we need to generate a list or an array of traits where all the possible traits from the board are only represented once. And for that, we have a static method called getUniqueTraitsForUnits. If we press and hold Control and click on it, you'll see that we already handled this logic inside the trait resource back when we implemented this feature. And then we can sort of just reset both member variables. We'll say that we have no active traits, and the unique counter, the dictionary with traits and integers, will be empty as well. So we always recalculate everything. This is maybe not the most efficient way to do this, computationally speaking, but again, you don't have to optimize when there's no bottleneck. If we see performance hits from always recalculating this, then we can refactor, but for now, let's just go with the simplest solution, right? So then what we do when we have the list of unique traits is we iterate through them, grab the unique unit counter, which we have another method for. And if we have that information, then we can update the dictionary, right? Grab the current trait as the key and set the value to the unique number of units inside the dictionary. And then we just need to decide if the trait is active or not. When we have the unique number of units, if it is active, then we can append it to the active traits array. If it's not, then we won't, right? Simple as that. And finally, when we are done with everything, we can emit the traits changed signal. So the UI will get updated and we'll pass the dictionary and the active traits array as parameters. And that's about it. Extracting out this functionality is pretty simple because we already have the groundwork laid out for us, right? This is probably one of the more complicated or complex pieces of that puzzle, getting the unique traits for units. And also this one, right? Counting the unique number of units for one specific trait. But since we already done both of those in the trait class, we don't really have to redo this, right? So now we have this TraitTracker with all that information ready to be emitted or queried from the outside. So let's save this script with Control S and let's add this TraitTracker to the arena, right? So let's go back to 2D view. Since we don't have anything like this here, let's, with the arena selected, let's click on the plus sign or press Ctrl A and search for TraitTracker, press enter or click on create. Let's drag this up above the UI. And let's not forget that we need to set this external dependency because we need to have access to the arena grid. So we know what units are on the board currently. Click on assign and double click on the arena unit grid. Now let's save this with Control S, and if we run the game, what do you think should happen? Well, nothing really, right? It still works. I can still do everything I could before. The elf trait gets activated when I drag Harry on board and it works, right? Well, yes, but we don't really use the TraitTracker. So if we close the game and take a look at the UI, and click on these traits, you see it still has access to the arena grid, which is kind of a telling sign that it does these active trait calculation by itself. If you click on the script button, you'll see that we have this active traits array. So the UI still does this on its own, even though we now have the TraitTracker. So we'll have to refactor the UI. But before we do that, it would be nice to actually test if this whole thing works, right? So what we can do is when we update the traits, we can just print both the dictionary, like unique traits, maybe put a new line between them and print out the active traits as well. So with this test code added, if we play the game again, oh, by the way, I wanted to show you something. It's a bit annoying that every time I run the game, the output window gets added, and this can be turned off. So if we go to editor and editor settings, and search for bottom panel, you can say that action on play is to open the output. You can set it to do nothing, then you don't always have to collapse this panel, or you can open the debugger by default. I changed this to do nothing, but in this particular case, it's actually useful because we want to check the output. So if I buy some units and drag them over, you'll see that we have the output, but it's not really helpful because we have these resources with identifiers, right? And it's kind of hard to tell what this is. And the reason why is because the trait class, the resource itself, is a resource, and for resources, the default string representation is just typing out resource and having that identifier next to it. So if we go to the trait classes script, one way to replace this is to override the toString method. So if we do something like this, we can override it by returning a string, and let's say we'll use the trait's name and say something like this: trait colon space and the name of the trait, right? That's a better representation than just typing out resource. So by adding this line of code here and saving this with Control S, if we run the game again, buy again some units and drag Robin in, now it's a much more useful debug information, right? So if I drag Robin in, you'll see that we'll have one elf and one ranger, and the active traits array is empty because none of these are active, which is fine. If I drag Björn in, we have 4 traits with 1 each: fighter, Viking, elf, and ranger. One thing we can test, if I drag in another Robin, ranger and elf should remain 1 because these still count as 1 as they are the same unit. Now if we buy some XP and drag a Harry in, we have 2 elves and 1 of each for the other ones, and the elf trait gets added to the active traits array. And this actually pretty much represents the state of the game perfectly well. We have the same thing on the UI, right? So if we know for sure that it works, we can go back to the TraitTracker and remove the print statement, because this was used just to confirm that it works. So we are sure that this does the same job as the UI does now. So we can refactor the UI next. If you like my content, please consider checking out my Ko-fi page, where you can donate one time or become a member and get early access to all my content and videos. So now that we have our brand new TraitTracker ready, we need to refactor the existing systems to rely on it, right? So we don't calculate the same thing in 2 different places. If you press Ctrl-Alt-O and search for trait, you'll see that we only have 3 other files besides the new TraitTracker. We have trait, which is a resource, traits, which is the UI control node, and we have trait UI, which is the dynamic representation of one specific trait in the UI that we instantiate. So let's start with the trait resource first, and we'll see what we need to update in each and every one of these. Now, the first thing I noticed when I opened up this class is that it doesn't really follow the convention that is suggested by the docs. So we have this page which details how we should order the code in each class to keep things consistent. And I always try my best to code this way, but sometimes I mess up. And in this case, we have the static methods at the bottom of this class. And it actually is suggested to start with the static methods before even the built-in virtual methods like ready and process, right? So if we take a look at this class, we have get trait names and get unique traits for units. And these are both static functions, which are not tied to one specific resource. So let's just select these, press Ctrl X to cut them. So we delete them from the text, but put them in the clipboard, delete these empty lines, scroll all the way up and paste them back in like so. So now we have the static functions at the top, then the public methods, and finally the private ones. Again, this is just to keep the consistency, so I try to be as consistent as possible. It doesn't really change any functionality of this resource. Now, another cool thing I wanted to show you, which is not really important, but a cool addition to the engine nevertheless, is that for the highlight color code, when a trait is active, we use the constant, which is a string for the color, right? But if we change this to a color object, a color constant, like so, then we get this color picker added to the code editor, which is a really nice addition, I think. So if you're not happy with the color, it's much easier to edit it this way. But this also means that we need to change up our code a bit, because if we scroll down, we have this piece of code here where we generate the BB code for this trait, and we'll use this as a placeholder, right, for the color. And the problem with that is the string representation of a color is not necessarily the same string as we have here. But what we can do, since this is a color object, it has its own methods. So we can just say to HTML. And we have one parameter with alpha, which is a boolean, whether we want the alpha color added as well. And we don't really care about the transparency for this, so we'll just set it to false, right? So what this does is it will grab that same string. So this is essentially the same as typing this here, right? So when we change the color, we get those 6 hexadecimal digits here. So it will work the same. If we press and hold Control and click on it, you'll see with and without alpha how this works. So if we have a white color, it returns 6 Fs. And this is exactly what we want to insert for the BB code. So this small change will make sure that everything works. These are just cosmetics, really. So for now, we don't really want to change much, but we have to revisit this resource later on. What we do need to change is we have these unit modifiers, and this was supposed to represent the trait bonuses back when we added this resource, but we didn't really have an idea how we want to implement this system. So we can rename this to trait bonuses, and this will be an array of trait bonus resources, but we don't have those yet. But let's just type it anyway. We should get an error message that we don't have this type ready. But for now, we shouldn't worry too much about this. We can just turn this whole line into a comment for now, and we'll just go back to this when we have everything else in place and we can actually start adding bonuses, right? So for now, to just make sure that the UI works with the new TraitTracker, we don't really have to change anything else here. So we can close this file. Now let's see the trait UI next, which represents one trait in the UI screen. So the way we do this now is we have this update method, and this is the most important one, right? All the other ones are for visual purposes and setting the data to the proper one. But here we have this method with the outside dependency of having an array of units passed in. And then we use the resources getUniqueUnitCount method to grab how many unique units we have for that specific trait that this UI piece represents. Now, what's the problem with this? If we go back to the TraitTracker, we have this unique traits dictionary, right? And how we populate this dictionary is that we call the same method that is called inside the UI, right? And we set the key to the trait, and we set the unique number of units to the value of the dictionary. Now, do we really need to recalculate this? Again, this is a UI piece that wants to display information, and we do calculations here. It's not the worst one because we just call a method from the trait resource, but still we don't have to and we don't want to calculate things twice. If you think about it, the traits control node, which handles all the traits that are displayed in the game, will have that information from the tracker, right? Because the dictionary, we saw that is populated with these unique counts. So we don't have to recalculate it. We'll just say that we need this number here, right? So what we can change here is change the dependency of this method. Instead of saying that we need an array of units for the trait UI to work, we can just say that we'll have the unique units already passed in as an integer, and we don't really need this line anymore, right? Because we'll just have 2 or 1 or whatever it is that number we have. There is a downside to this, because if we do this change, it also means that it's harder to test on its own, but this is debatable, right? Because I can just call this method from the ready callback and pass in an arbitrary number and see if it works or not. It just has to display the data, so we don't really have to worry about it too much. This is the data we need, and we'll get this somehow. We don't want to calculate anything again, because we only want one place to store this up-to-date information. Having one specific place to store the state of the game is always better than having different places holding the same data. Because if there is an inconsistency between the two, then you have a big problem you need to manage, right? So we have the tracker, it always keeps track of the things, and the UI will just be notified that this many units are there, update yourself. And it does so, right? Changing the label, generating the BB code, and so on. Okay, cool. This is a pretty simple change. Now the last one is the traits.gd, which is that control node that we have in the arena, right? This one, if we click on open in editor, you'll see that this is the one that holds all the trait UIs. If we take a look at it, this is the big gun, right? This is what we need to change up to make sure that it relies on the TraitTracker and doesn't track things like active traits for itself. Okay, the first thing we can change is we can get rid of this arena grid dependency. We no longer need it. We want to connect to that signal, right? Do you remember? We said that there will be a signal emitted when the traits have changed. We just want to connect to that signal. We don't really care about the arena grid ourselves anymore. We can delete this. We don't really want to track the active traits either. We can just delete this. Inside the ready callback, since we no longer have the arena grid reference, we don't want to connect to that signal. We can delete this as well. We're just trying to make it easier, right? Now, the update traits method is where we'll have a pretty significant change. This method in the past have not received any parameters. Now, what do you think we need from the outside for this to still work? What parameters should we add to this? Since we want this signal, when the traits have changed, to connect to this method, which updates all the traits, those are the two pieces of data that we need. The dictionary for all the unique traits and the active traits array with all the active traits. So we'll do exactly that. We pass in both of those pieces of data. And when we have that, we no longer need any of these, right? We don't need to grab the units, we don't need to grab the traits, we don't need to reset the active traits array. All of those will come from the outside, right? From this one. Now this we keep because all the logic that we implemented for the UI itself is still relevant, right? We still have to decide when it changes whether these traits that we want to update are new, because if it's new, then we have to create that instance for it. If it's not new, we have to update it. So all this logic is still intact. We just need to make sure that all the data is updated in terms of where we get them from. So for example, we have this error message here where we iterate through all the traits we have. And this is fine, but we don't really have a traits variable anymore. But we want to iterate through all the available trait data. So we can just use the unique traits parameter for this, because the keys will be the traits, right? So if we type in unique traits, it means that we iterate through all the keys of this dictionary. Now we have this units parameter, which was an array of units when we update or create a trait UI. And if you remember, this is the chain of events we need to understand, right? We call this. And for each trait, we either update an existing trait UI or create a new one. And when we create a trait UI or update one, what we do is we spawn it, set the resource as the data, and then we call this update method we just changed. And this is why we had an array of units there previously, because we did that unique units calculation here. But since the TraitTracker does it, we no longer need to pass the units as a parameter. We no longer need an array of units for these methods. Instead, what we'll do is we'll just grab the unique units. So instead of units, we'll type in unique traits, and the key we use is the current trait data, right? So we loop through all the keys, and using this array notation with dictionaries means that we grab the value instead that key represents, which will be the integer. Again, we'll get the error message because we need to change these two methods as well, but this is the change we need to do here for this to work. Now, we also have this move active traits to top call when we're done with that. And if you take a look at this method, we iterate through the active traits and move those UIs up to the top. Now, the problem is we don't have any parameters here, right? So we have this error message because we no longer have this active traits member variable, but we do have this as a parameter to the update traits method. So what we can do is we can pass this to that method, and we get a new error message, right? Because the definition doesn't have any parameters specified, but if we add it here as well as an array of traits, then this method works as well. Deleting the orphan traits will be the same, so we don't really have to change anything here. Now we just need to handle these two methods when we create or update a new trait. The easiest change is that since we no longer track active traits inside this class anymore, we can just delete those ifs for both methods. And now the only error we have is when calling these two methods and when calling the trait UI's update. So what we need to change is, instead of relying on an array of units, we can just grab the number like we talked about for both methods. And when we pass in the parameter to the trait UI class's update, we change that as well to integers. So if we replace those with the unique number of units, then we should be good to go. These are all the changes. I know it might be a bit harder to follow, so let's just go through it again from the top, okay? So what we did is, first of all, we got rid of that arena grid dependency. We no longer need that. From the outside, we'll just connect to the TraitTracker signal. Then we deleted that array of trait resources, which kept track of all the active traits, again, because we get this as data from the tracker. Inside the ready callback, we connected to the arena grid's unit grid changed signal, which we can remove since we no longer need access to the arena grid at all. And this is where we did most of the change. This is the entry point of this UI, so to speak. So what we do is instead of having 0 parameters, we have 2 now. One is a dictionary where the keys are the traits, and the integer is the value, which is the unique number of units possessing those traits. And we have an array of all the active traits since we already track this here in the TraitTracker. Now, one small thing we can also change, and let's not forget this is super important. And the question I get a lot, why do we have a leading underscore here, or why not? Having a leading underscore means that this function should be private, which means that it should not be called outside here. I want to delete this underscore to make this essentially a public method, meaning that this will be used outside of this class. Why do you think we need this change? When do we want to call this function? We want to call this function when this signal gets emitted that the traits have changed. Whenever they change, I want to update this UI to represent those changes, right? Question is, where do I connect the two? I need to find a common ancestor in the scene tree, right? So if we go back to the arena, we have the traits here, we have the TraitTracker here. So where can I connect these two pieces together? Well, the common ancestor would be the arena node, which is a good guess, right? I have to connect the TraitTracker's signal that gets emitted to the traits control node's update traits method. Since I connect those two outside this class, it becomes a public method, hence removing the leading underscore. Okay. Now we have this. Here we had 3 other lines for holding data that we no longer need, which was removed. And then we changed both updating a trait UI and creating one. Instead of passing the units themselves, we'll grab those integers from the dictionary, which displays to us how many unique units we have for a trait. So when we loop through this, in the first iteration, the trait we examine will be the elves. In this case, this number will be 2, then we go to rangers, this number will be 1, right? So we want to introduce this integer, because when we update a trait UI, we only care about the number, right? So we did this both for creating and updating a trait UI, and also when we move the active traits to the top, we no longer have this internal member variable which keeps track of all the active traits, but we have it as an outside dependency from the signal. So we can just pass in this as data. We did nothing with the delete orphan traits, but we also need to update both this method, this one, and this one, because we changed the parameters they take, right? So we did the same thing for these two. First, we changed the parameter from an array of units to an integer. Then when we call the update method for the trait UI, instead of passing an array of units, we want to pass this integer to it. And we also had 2 if statements for both these methods at the bottom for tracking the active traits, but we no longer need that because, again, we get it from the outside. And when we move the active traits to the top, what we needed to do is we needed to add active traits as a parameter to this function, and then the logic remains the same. right? So that should do it. If we save this with Control S, hopefully it makes sense how we did this refactor. And now we can see that this UI script is only responsible for displaying the data. Now what the problem will be, if we run the game and try it out, nothing gets displayed. No icons here. Why? Nothing on the output either. What did we screw up? See, the problem is this method never gets called, right? We have this method to update the traits according to the information, but it never gets called because we didn't connect to the TraitTracker signal yet. And we said that we should connect to it inside the arena because it has access to both of these nodes. So if we click on the arenas script, you'll see that as already variable references, we have neither of these, right? So for the traits, let's right click on it and access it as a scene unique name to make sure that the node path is simpler, and press and hold Control while dragging it over to the script. Let's release the mouse and the Control button and do the same for the TraitTracker. Now the TraitTracker should be moved up because I kind of want to keep the same order of these variables that they represent inside the scene tree. So I press and hold Alt and press the up arrow repeatedly to move this up under the unit combiner. So now that we have access to both of these, we can actually make that connection, right? So inside our ready virtual method, we can do something like TraitTracker.traits changed. This is the signal that we emit, and connect it to the traits UI's update traits method. And this is why we remove the leading underscore, right? This makes it public because I access it outside that TraitTracker or traits class. And it would look really weird, right? If I had this leading underscore next to the dot, right? So we have this, and if we save it with Control S and play the game again, we should have our trait tracking back, which works the same way as it did before. And if we buy some XP and buy Harry, you see that it gets activated. It is moved to the top, right? When it gets activated. So everything works the same as it did before, and it was kind of a longer and a bit more painful refactor, but we did win out a lot because when we add the bonus system to the game, it will be much easier to make that communication line between the battle handler and the TraitTracker, right? Because the TraitTracker always has this information available on the member variables, whether the traits are active or not. And the battle handler will need that information if we want to add the trait bonuses when the battle begins.